Question 6 on this paper comes with a diagram. It's showing the curve y equals x squared plus 5. The point A has the coordinate 1, 6. The point B has coordinates a squared plus 5, where a is a constant greater than 1. The point C is on the curve between A and B. In the first part of the question, find by differentiation the value of the gradient of the curve at point A. So this is the curve we have, y equals x squared plus 5, and by differentiation that means we need to find dy dx. So if you differentiate x squared, the 2 comes down the front and you knock 1 off the power. If you differentiate a number with no x's, it disappears. And 2x to the power of 1 is just the same as 2x. And at the point A, which had the coordinate 1, 6, well, that 1 is an x number, the 6 is a y number, so we now know here that x is equal to 1. So we stick x is 1 in there, and instead of having 2 times by x, that will give us 2 times by 1, which is 2. So that is the gradient of the curve at the point A. The next thing we have to do in part 2, it says the line segment joining A and B has gradient 2.3. Find the value of A. Well, the line segment means if they joined A and B with a straight line, its gradient is 2.3. So I'm just going to do a sketch of that. So we've got A is the point 1, 6. B is the point a squared plus 5. And we've got this straight line joining them up. To work out the gradient of this line, we need to basically make a right angled triangle and look at the changes from left to right. To find the gradient, we need to do the vertical change divided by the horizontal change. And one formula you may have for the gradient is y2 minus y1 over x2 minus x1. And it can actually work the other way around. As long as the numbers are the same order on the top and the bottom, it doesn't matter. So if your teacher's given it the other way around, that's fine. I'm going to use this one here. y2 is the y coordinate of your second point. Well, this is my second point, and the y coordinate is a squared plus 5. From that I have to take away y1. That's the y coordinate of my first point, which is 6. And that's all divided by x2, which is the x coordinate of my second point, which is a. Take away x1, which is the x coordinate of my first point, which is 1. So that is the gradient. But the question tells me that the gradient is 2.3. So what I have to do now is I have to solve this equation, which has got a's and a squareds in and numbers in. I have to solve this equation to find out what a is. So let's have a look. On the top, I've got a squared plus 5 minus 6. Well, that's the same as a squared minus 1. So on the bottom, I've got a minus 1 and equals 2.3. The fraction is bad. You want to get rid of the fraction. So all of this bottom part down here, which is doing a divide on the left, move it to the other side where it does the opposite thing. So instead of dividing, over here it multiplies. So we can write it like that. So on the right hand side of the equals, I can multiply at the bracket to get 2.3a minus 2.3. Now I'm going to get a quadratic equation. It'll have some a squareds in, some a's in it, some numbers in it. To get a quadratic equation, you always want it to equal 0. So I need to get everything now on one side. I want it as equals 0 on the right. So I'm going to keep my a squared where it is, on the left-hand side of the equals. I'm going to bring this bit here onto the other side. It's a normal 2.3a, in other words, a plus 2.3a here. So on the other side of the equals, it will be a minus 2.3a. I'm going to keep that minus 1 where it is. And I'm going to shift this minus 2.3. When it comes to the other side, it becomes a plus 2.3. And that now equals 0. So I've got a squared minus 2.3a, and minus 1 plus 2.3 is plus 1.3. So I've got this quadratic equation. Now, normally you don't deal with factorising quadratic equations with decimals in, but they're not going to give you a really nasty quadratic involved in this sort of question. So normally you say, okay, what numbers multiply together to give me 1.3? And the most obvious are 1 and 1.3. They times together to get 1.3, and usefully we can get 2.3 from them as well. So we can actually factorise that quadratic. Because of the a squared, both brackets will start with an a. If there's a plus in this position, that means both signs in the brackets are the same as each other, and they're the same as that. So I have a minus in both brackets, and a 1 and a 1.3. So I've factorised the quadratic, and I've got down to here. So once you get to this stage in a quadratic, bracket times bracket equals 0, you can say that either the first bracket equals 0 or the second bracket equals 0. And if a minus 1 equals 0, well, that means a is 1. Or over here, if a minus 1.3 equals 0, that means a equals 1.3. So I've got two values for a. But it does say in the question that a is a constant greater than 1. So this one here, it can't actually be that value in this question. So my answer has to be this one over here. So a is equal to 1.3. Then the third part of the question says, state a possible value for the gradient of the line segment joining points A and C. Now we know the gradient down at point A is 2. So the gradient of a tangent down there is 2. And we've just been told in the last part of the question the gradient of that line is 2.3. So the gradient of the line segment joining A and C, which will be this line here, has to be somewhere between these two values. So you can write down a number, any number you like, between 2 and 3. Sorry, 2 and 2.3. Anything in between will be the gradient of the line A to C. We know it's 2 here, we know it's 2.3 for this one. This line's in between. Anything between 2 and 2.3, you'll get your answer.